Hello everyone, my name is Sonication. Today I'll be presenting my research on the effect of acid leaching with sonication on AAEM removal of spent mushroom substrate under the biofuel innovation, which is supervised under Faculty of Chemical Engineering and Technology. This work is supervised by Associate Professor Dr. Alina Rahayu Muhammad and Associate Professor IR Dr. Umi Fazara Muhammad Ali. Alkali and alkaline earth metals or AAEM such as potassium, sodium, calcium and magnesium are naturally present in biomass. These elements originate from soil, fertilizers and biological uptake during plant growth. However, they negatively impact thermochemical conversion processes like pyrolysis and gasification. Specifically, AAEMs catalyze unwanted secondary cracking reactions, reduce bio-oil yield, and promote issues such as slagging, falling, and ash deposition. Overall, their presence reduces conversion efficiency, increases operational cost, and lowers product quality. Spent mushroom substrate or SMS is an abundant lignocellulosic waste with high potential for biofuel production. However, it contains high AAEM content with ash content reaching up to 17.37% in raw form. This leads to poor biofuel conversion performance. To address this, acid leaching combined with sonication is proposed. In this method, nitric acid converts AAEMs into soluble salt while the sonication wave enhance acid penetration into the biomass structure, improving mineral removal efficiency. The main objective of this study is to determine the optimal sonication duration and maximizes AM removal while improving the physiochemical and thermochemical properties of SMS biomass. The methodology consists of several stages. First, the biomass was collected, cleaned and dried. Then it was ground and sieved with multiple sizes, but we did choose 250 micron for proximate analysis and TGA analysis. For proximate analysis was conducted using TGA. Next, acid leaching was performed using 1% of nitric acid combined with sonication for 5, 10, 15, 20 and 25 minutes. Finally, thermal and kinetic analysis were carried out to evaluate decomposition behavior and activation energy. The result of proximate analysis showed that the sample treated with 20 minutes of sonication, known as SMS-20, achieved the best performance. The ash content was reduced significantly from 17.37% to 5.43%, which corresponds to a 68.7% of reduction. At the same time, the volatile matter increased by 43.1%, which is beneficial for improving bio-oil yield during pyrolysis. Ash and volatile matter. The result confirms that 20 minutes is the optimal sonication time. Shorter duration result in incomplete AM removal, while longer durations do not show significant improvement. Therefore, SMS-20 provides the best balance between efficiency and effectiveness. The thermogravimetric analysis shows a well-defined multi-stage decomposition behavior. The first stage, below 150 degrees Celsius, represents moisture evaporation. The second stage, between 200 and 300 degrees Celsius, corresponds to hemicellulose decomposition. The third stage, between 300 to 400 degrees Celsius, shows major mass loss due to cellulose decomposition. Finally, lignin decomposition slowly is above 400 degrees Celsius. This clear profile indicates improved structural uniformity after pretreatment. The DTG curve shows a small peak around 100 degrees for moisture, a shoulder at around 220 degrees for hemicellulose, and a major peak between 340 to 360 degrees for cellulose decomposition. This sharp peak indicates rapid and uniform degradation, confirming that cellulose is the dominant component in the thermal decomposition. The kinetic analysis. Okay. The kinetic analysis shows how activation energy changes across different stages. In section 1, which is moisture removal from 30 to 70 degrees Celsius, the activation energy decreased to 123.91 kilojoules per mole compared to raw SMS, indicating improved thermoreactivity. In section 2, between 140 and 280 degrees Celsius, the activation energy is the lowest at 76.69 kilojoules per mole. This shows that hemicellulose decomposes more easily after acid leaching and sonication due to structural disruption and removal of AAEM. In section 3, between 280 degrees Celsius and 360 degrees Celsius, the activation energy increased to 132.48 kilojoules per mole, indicating that cellulose remains more thermally stable due to its crystalline structure. However, structural modification from pre-treatment still enhance its overall reactivity. In conclusion, acid leaching combined with sonication is highly effective in removing alkaline and alkali earth metals from SMS biomass, which is known as AAEMs. The optimal condition is 20 minutes of sonication, which significantly reduces ash content. Meanwhile, it increases the volatile matter. Thank you.